Oh, okay. Okay. Yeah. So I guess we're gonna start right now. It's between me and lunch, so let's get started, and we can have lunch earlier or as early as possible if there's not much to discuss. All right. So this will be a quick update about the TLS 1.3 0 RTT. It's not TLS 1.30. It's 0 RTT. The font is kind of weird here, but it's a quick update for the 0 RTT support and some other SSL related stuff. So first of all, and this is okay. There's it. So some background information if you're not too familiar with the round trips prior to 1.3. So there are about 4 phases of accessing a browser, accessing a website. So the first phase will be a DNS lookup, then it will be the TCP handshake, which takes about 1 round trip, and then the TLS will take 2 round trips, and this is where the 1.3 0RTT will have its magic happen. And then it's the HTTP that takes another round trip. So in total, we have 4 round trips for a new connection and plus the DNS, and 3 RTT, 3 round trips for the resume connection plus the DNS. With the TLS 1.3, the 2 round trips got shrinked to 1 round trip for all the connections. And if you have the 0RTT enabled, it combines the round trip, the TLS handshake round trip with the HTTP. So the first request will be combined with the handshake, which effectively makes it to 0RTT. So that is where magic happens. And Cloudflare has done a test of some kind, and they have the statistics for the requests on their servers. It's about 40% is a resumed connections, so it's a pretty big performance update. So to enable the 0RTT in ATS, there's quite a bit to do. At least after I've done it, I found there's quite a bit to do. At the beginning, it seems so easy. We just need to call the OpenSSL APIs and everything should just work. But nope, they don't really document everything to sort of. So yeah, it turns out OpenSSL don't really like to document everything too good, at least not on their documentation website. It's in their GitHub issue list. So if you know where to go find it, it's there, but you need to know first. So it's like a circular thing. So anyway, in order to enable the 0RTT, you first have to call the set max early data. And early data is like the other name for 0RTT, because the data is like prior to the old request, so it's early data. Anyway, you need to call this, set it to like a good value to enable 0RTT, and the default value is 0, which means basically nothing will be allowed to be sent to the server. Any other value that's greater than 0 will effectively enable 0RTT, and the default we have is 0, which is by default disabling the 0RTT support. And I also have 1 config added for this that's in records.config, and I'll talk about this a little bit more afterwards. We're thinking about moving that to a different file. The second API call we need to do here is receive max early data. This is kind of confusing. Like when I first did this, we have a separate configure option for this one. But after lots of discussion on the PR, we decided we need to remove this because this is so confusing. No one understands what it does, and we can kind of set it automatically. So we removed it, but effectively this is setting how much data the server will be skipping over. So it's like the first option here will set how much data we can accept. And the second one is if the data goes over the first limit, but less than this one, the part in between gets dropped and got ignored. And then if it went over the second limit, the connection is aborted. At least that's how it, the fake documentation made it seem like. So right now we're just making the two values the same because that's what OpenSSL suggests. It has to be at least the same size as the first one. Otherwise, every connection will be aborted, almost. But yeah, the default value will be 0, and if it's if 0 RTT is enabled, the value will be set to the same one as the first one. And okay, there's another 2 steps we need to do. Actually, one step for the options, and the other one is for the AntiReplay. This one is basically saying we need to disable the built-in AntiReplay by OpenSSL. This is also not documented. I went on their GitHub and searched through all their previous PRs and issues, and finally found this. Someone was having trouble enabling the 0 RTT like I was, and then he did a few tests, and then the OpenSSL guy says, oh yeah, we kind of have this AntiReplay thing. You can try turning it off if you have external cache. And that guy did and fixed their problem, and he said, okay, yeah, we're closing this issue now because this is fixed by turning this off, but it was never mentioned in the documentation. So we have to do that. And then after some testing, after implementing the whole thing and did some testing with the external cache, I turned the internal cache back on again, and then found out I have to disable this for the internal cache for us, at least, because we're using non-blocking accept calls, and that's confusing the OpenSSL. So it thinks bad things are happening, so it's dropping the data, and we have to disable it. But we don't need to be too afraid about disabling the AntiReplay because we have our own AntiReplay mechanism here. This next option is kind of a part of it. So we have more AntiReplay stuff, but this one is just controlling if we are allowing parameters on the request. So if we enable it, then we allow parameters. If we don't enable it, we'll not allow parameters, and it's disabled by default. So that's all the configuration and setups. That's the most tiring part, the most hoops I have to jump through. Any questions so far? Yeah.
Where did the commenting?
Where do I what?
Where did the commenting?
It's in the code for now. It's in the PR state. So if you want me to make a separate documentation, I can make it. Yeah. Well, the implementation itself is not too bad. It's just some super simplified pseudocode. So basically, just replace. This is for the accept, SSL accept. So instead of just calling SSL accept directly, we need to do some extra steps. We we detect if there's any early data. If there is, we grab it and put it into a separate buffer. And after that, we still need to call the accept because we need to get the connection going. But the early data is stored in a separate buffer for now. And then we see if the return value is finished or not. If it's finished, then we go do whatever is supposed to be done originally and keep the session going. And the next step will be the SSL read. Because we have early data, we need to check if the data buffer is there. If there's anything in the buffer, we copy all those into the SSL read buffer. If there's not, we go back and do the original read. And we also need to check if early data, like the return value says it's finished. If it's not finished, it means it might have more in the early data, like data flow. So we need to go read it again. And the code will be basically the same as the accept one, except for reading to the early data buffer is different because we are already in the SSL read. We just read directly into the buffer, the read buffer. So everything will be there. We don't need to go to the early data buff. And the SSL, the early data write will be even more simpler because just replace the normal write with the early data write, and that's it for the write because that's how it's done. So after this PR has been created, we were discussing about the AntiReplay part because it's vulnerable to AntiReplay, and it's mainly because if 0RTT is enabled, it's not forward secure, so AntiReplay will always be a threat. So we have to implement something to protect ourselves. So good picture from Wikipedia. Yay. So the AntiReplay mechanisms we have right now is combination of a few different things we've read from different sources. So the first one is a comment, again, not documented, a comment on OpenSSL's GitHub page. It says, yeah, we should only allow tickets once. If it's being used, then it should just be replaced with a new one. And this is fairly easily done by just manipulating a return value from one of their callbacks. And this is good enough for one server. So if it's just one server, yeah, this is enough because every time you access it, it will be on the same server, and the server will see, okay, the ticket's being used, we are replacing it with a new one. But if you have a fleet of servers, this will not work because the tickets are not synchronized between. So we have to have a different mechanism. And that's actually the third one here, but I'll talk about the second one a little bit more before that. So the freshness check is similar to the first one, and it's also built into the OpenSSL. So we don't really need to configure anything. It's already done. It kind of works the same as the first one, just it does the check on a timeout basis. So after a certain time period, it will just replace the ticket, and everything will be fine. And since this is kind of similar to the first one, it's also per server basis. So yeah. So the third one is I think it was done by Cloudflare first. At least we saw it on their blog post. So what they do is they just limit the access to only allow safe methods. And what we are doing here is we are only allowing GET and HEAD requests. And this is actually Leif's comment on the PR. We are still discussing it. Yep. No. Yes. Yeah. I think you have to have parameters.
Is that bad? Is that bad?
Yeah. Yeah, I mean, in that case, we can kind of have an option to say, set a limit to that and then disable the RTT if that kind of things happen. Yeah. Yeah. Yes. Hmm. That is a good idea, kind of a good idea, and it's kind of similar to what we have later on, but
You have to remember it if you got early data. It's kind of messy, but you can.
If we're, I mean, then if you could do it in remap or that area, can you just say if it's, because then it's, then it'll, if it's cached, if you know it's cached, then the method doesn't matter. Yeah. Yeah, but remember, this is where LinkedIn really messed up the 6.0 release because of this. Yeah, this is retries of this.
remember, Leif is always right. So I remember on the PR we had a discussion about whether we allow like what the RCF decides as safe methods. It has another one, kind of a gap, and then yeah, I think it's options. But then Leif said we want to have only get and head. We can discuss that later, but this is what we have for now, and that is basically everything for the ZRTT part. Is that the timer? Yes, that's this part. Yeah. But before that, promoting our plugin here, we have a SSL session reuse plugin. It's good. So it works, and everything's tested in production. Yeah. So this is open source. It's part of the experimental plugins. Yes, it's in the experimental plugins folder. So if anyone's interested, they can try using it. If there's more bugs, just let me know. I'll help you fix it. So, yeah. This one? Oh, the RTT. Yeah, I haven't fixed that yet. I recently did a little bit cleanup and I think trigger something. Yeah. So just more discussion if we have any. One of the requests on the PR is we move the configurations into sni.yaml, so it will be able to set for different server names. And yeah. Okay. Sure. Any other suggestions? And I have a question actually. When we actually want this, because has been in a PR state for about half a year. It's I think I put the PR there after the Beijing summit. So do we? When do we want this? Like the RTT.
When do we want to land it?
We should land on a master before 9.1.
Yeah.
Too late to put it into 9.0. It just, as much as we want to see it, it's just minimize risk. Still have problems.
Okay.
We shouldn't stop it. I mean, let's move ahead and get this on AS.
Yep. It's almost ready. I just need to have a few cleanups, and I think not moving, like overriding settings options in the sni.yaml will be a separate PR. Like the core is already done, so.
Always because in the situation, but without clients doing zero RTT, it's hard to test the servers. Clients can't test without servers and
Yeah.
You guys have clients that use their RTT?
clients that do zero RTT.
No, I'm saying you have. You have clients that do RTT.
All right. So I guess that's it. Thank you.